Hello, this video will be going over the G150 pocket mill assignment. This brings in a couple of new concepts. One being naming that we're going to be machining out this circle. We're going to be using that with a can cycle. And then also this inside pocket right in here. There's also a can cycle for that removes all the excess material on the inside versus trying to figure out where you need to cut to remove all that material. First of all, we'll just kind of go over the part. So first thing you're probably going to do is face off. I guess we can kind of go over these features here a little bit. So first thing, or one of the things you're going to do is face off. More than likely be the first thing. You have the outside you have to do. You have that outside step. You have the inside pocket. And then you also have that 1 1/8 circle. Along with also you have your holes. Okay. So we had talked previously about plunging down, in particular that 4-leaf project, that an end mill does like to cut down, but it has to be a center cutting end mill. And the roughing end mills that we have here at the school are not center cutting end mills. So you're definitely going to want to drill this out here before you go in there with your G30 or with your can cycle to perform that circle. So you might want to consider actually doing your holes after you do your face. You definitely want to do this to eliminate tool changes. It doesn't pay to rough and finish the outside. Bring up your drills, drill your holes, and then bring up your same roughing tools just to do the inside feature. Now sometimes there is a case where you have to do that. But there really is no reason why you can't drill your holes first. So you might want to take into consideration doing that because you do want to minimize your tool changes to be productive. And along with that, the holes, you're also going to be drilling a 3/4 inch hole in that center to help out with that 5/8 end mill. So you'll be adding that tool also to your tool list. So knowing that those features, that's what you're going to be doing. The outside, you're going to take down to 750. Probably going to do that in 3 passes for your roughing end mill. And then you have the inside step, okay, to do that. That you can do in 1 pass down to that 3/8 right away. That can be 1 pass. Mainly being that you only have this much material left on that outside, so you have very little, basically 1/8 inch, a little bit more on the corners, but you have that 1/8 inch to take out, so you can do that all in 1 pass. Now, one thing when you're machining around this outside, let's say if you start up here, you're going to come down. You want to make sure you finish when you come up, come over. You want to ramp off and then do your G40. To finish that chamfer. So you want to make sure you keep that in mind when you do that. So then you do your roughing cycles. You're going to jump inside and do the can cycle for that circle and the can cycle for that inside feature right away. When you do that, make sure when you're done here, you go to Z.1, a positive Z, above your part. Otherwise, when you come across into the middle, you'll end up obviously breaking your end mill. So you want to keep that in mind when you travel to the center. The holes, you should be able to know how to handle those by now. They're just drilled holes, so that shouldn't be that difficult. You can chamfer chamfer your holes right away. It'd be a little bit. One thing you can add in afterwards is to chamfer these holes after the pocket's done. Now, I did say there's times where you want to minimize your tool changes. This is one time where it would be beneficial to recall that chamfer tool and then just chamfer these 4 holes. Now, keep in mind you're going to be at a different depth than the top, and that's the reason why you can't do that the first time you do it through, because you can't chamfer that deep with that tool. So after the pocket's in, then you can come in and just chamfer those holes. So that would bring us up on how to do that circle and how to do that inside feature. The circle you're gonna use, we'll cover that first. You're gonna do what they call a G13 can cycle. I'll switch over to our manual here just to kind of discuss that. In your manual on page 140 starts out the discussion of the G13. See if I can get my pen going again. There we go. See, the can cycle is actually a G12 or a G13. The only difference is one's a clockwise and the G13 is a counterclockwise. Remember, if you have an inside circle, if that's my feature, I always want a climb mill, so I always want to be going that way, which is a counterclockwise rotation, which for the most part you'd be doing G13s. So inside the G13 can cycle, you need a certain codes. The X and Y location are optional, just because you can get to your center point. It's the center of the circle. You can get to it in the lines ahead of that. You're going to have a Z depth. You more than likely are going to have the radius of a first circle, the radius of your finished circle, and a step over amount. You definitely need the D for the cutter comp. So if you're using tool 1, it's going to be D1. Tool 2, it's going to be D2. And then you need a feed rate. And then depending on which type of G13 you're going to be using, you may use an L code. So the manual in the next few pages kind of goes over a few things, a few of these examples. This here would be on page 141. It's just for a simple one pass. It's going out, it ramps into that circle, does that circle, and it ramps off. Okay, just one pass. So it's not really used for something that has precise tolerances. Maybe you just want to roughen the circle. It's a clearance for a bolt or something like that. That would work just fine. So this first example just kind of goes through. Now this would be for almost an example if there was a pre-drilled hole already, because you're going to feed down at 10 inches per minute. It goes out a ½ inch, so that's a radius value. So we're doing a 1 inch circle, and it's doing it at -0.5. The next example is if for some reason you wanted to plunge down with your end mill and you wanted to feed down in a different rate. Well, you just add a line right before your G13, G01, Z -0.5 at a slower feed rate, and then you can just call up your G13. Okay, notice you don't need a Z value in there. If you had a Z value in there, it's no big deal. It'll just stay there. So they're kind of very similar, just that the only thing is this one here feeds down at a slower feed rate to finish your pass. Now the next ones are a little bit more common. So this is if your circle is quite a bit larger and you want to work your way out in steps, and those steps would be your Q value. Once again, these examples are very similar. The only difference with the second one on page 142 is that it feeds down at a slower feed rate. Otherwise, the examples are the same. So you got G13, Z -0.5 is your depth. I is the first circle. Okay, so that's the first circle that it's going to cut. All right, so in our case, if we use a 3/4 inch drill, I is going to equal 375 would be a good value, half of that. Remember, it's a radius value. K is a finished circle. Okay, so that goes all the way out to 1.5 radius value, so we're doing a 3-inch circle. Q is the amount it's going to step over every pass, so it's going to go out to I, 0.3, and it's going to go out to 0.6, 0.9, and so on, all the way out to 1.5. And then you have your feed rate and your D value that you're going to need. So this is, like I said, probably the most common one you're going to use. The reason why I like using this, if you can take that full depth, you can take advantage of the sharper part of a cutter that generally isn't used. The dullest point of any cutter is the bottom third. So maybe we can take advantage of that topper part of that cutter. The only thing is maybe you want to use a smaller step over, like maybe 50 thousandths if you're taking a little bit deeper depth of a cut. So you got to keep that in mind also. And the other example that they do is if you want to step down in the Z. The first part of the line, they're almost identical. That's your first circle, your finish, and you step over, you got your D, you got your F. Now we do add a couple of new things in here. Notice that there's a G91, so it goes into incremental units. And then there's also an L, okay? So what this does, what this is going to do, it's going to go down 375, and it's going to take 4 passes at 375 deep. So that'll give you a pocket that's 1.5 deep. So basically you would do 375 times 4. That tells you how deep you're going to go. So let's say maybe if you have a 1.5 and you only want to take a 1/4 inch at a time, your L would have to be 6 if you're taking a 1/4 inch. I would want to say that L would be 6. That's still going to give you your 1.5. So if you have to kind of determine how deep you can take, what your cutter can handle, and then figure out how many passes you need from there. So like I said, very similar to the previous one. So also a very effective way to do it. But then keep in mind, because of the G91, you have this G90. You have to go back into absolute units. Big mistake is if people don't do that. Okay, if they left that out, let's just say that wasn't there. They went down 1.5 inches. It goes G00, Z1 point. At this point then, if that was the case, you would still be at negative 0.5, and more than likely when it goes home, it would break your cutter. So it's important to make sure you put your G90 back in there. Okay, so that'll get you through that G12, G13. So now we have this inside pocket. If you didn't have a can cycle for this, you would have to figure out where your cutter can go to clean up that inside, make sure it doesn't leave anything. You have to zigzag back across. Of course, they also don't want to make sure you don't cut too far. That really becomes a problem when you get into radiuses. Make sure you don't cut into your part. So there's a can cycle that kind of figures all that out for you. And that's on your manual, starting on page 150. So this really gets into subroutines. It uses a subroutine without really calling it out. Our next project is going to take advantage of subroutines a little bit more in depth. General purpose pocket milling. So inside your G150, you need a couple codes that are required. You have an incremental step. You need an I or a J, and that's how much it's going to step over for each pass. You need a finish cut allowance. You definitely need your D. What cutter comp are you using? You need a feed rate. And then the P stands for your subprogram. That's going to be your profile. It does tell you that you need R. It really is not necessary if you write your program correctly, and we'll go over that in a little bit. So on page 151, they give you an example of pocket milling with the G150. I'll kind of pull it up there, 150, 152 is an example. So this part here is actually doing a pre-drill for the starting location. Okay, notice it's a G81. So this is basically just putting a starting, pre-drilled your hole right there. Okay, and then here's where it starts like your G150 and then your subprogram. So you notice once again that the first 4 lines, very similar. Okay, starting location, center of your pocket usually, RPMs, tool lengths. It comes down to Z0. That helps if you do that, and the G01. And then you got your G150. So your P stands for your sub-program number. This is actually going to be a separate program altogether. So you just make up whatever your program number is going to be, and then you're going to actually go into list programs and create a new program, in this case 101, and then write sub-program. Okay? I is your step over. I is going to step over an X distance. J would step over into Y. You have to have one or the other. You can't have both. K is a finish allowance. You're going to use cutter comp left, your D value. This is your finish depth. And this is how much it's going to step down. Sorry about that. This is how much it's going to step down in the Z every pass. And typically I leave out the R, and then you need a feed rate. So once you have this established, you have to go ahead and write your subprogram. Now in your subprogram, the subprogram is just the profile of the part. Okay, so you're going to pick a point. I believe our example picks this over here, but it doesn't matter. You would pick probably something in the center. Okay, so you're going to pick your point and you just go from there. And you're just a profile of the part. And your start point and end point needs to be exactly the same. So that's your subprogram. Notice right here, subprogram right here. So it goes to x.5, it goes all the way around, comes back, it finishes at that exact same point, and then the M99 needs to be there. So it says return to main program, which is back up here. So after it does its number of depths down, cut down in the Z, so it's probably going to do, where's our Z depth? 1 inch, so it's going to do 4 passes, 1/4 inch each. And once it's done with that, notice that next line right there is G01. G40 cancels our cutter comp, and it goes back to our start point right there. Okay? And then this is all we're doing in this example, so you have your same 3 lines that end it. So it's a very effective can cycle, and it works very well. You just got to keep track of that. The big thing is to make sure your subprogram is written correctly. What I recommend doing when you write this, put a feed rate in of anything. It could be any feed rate, and your graph should run, and it should just keep on going around and around and around. It just keeps on cycling because of that M99. There is no main program now. Okay, so once you get it to do that, you kind of prove out your geometry, your I's and your J's, then go ahead and take out your feed rate, and then go back to your main program and try running it. That kind of proves out, because you get the same error if there's an error in here, if there's an error in somewhere in your program, or if there's an error in your can cycle. So by doing that feed rate thing, you kind of eliminate your subprogram. So good luck with the project. If you have any questions, please come and see me.